But introduction to stats, the idea is we have to have statistical and critical thinking, types of data, and then in the next section, we look at how we collect sample data. We are going to look at statistical terms. We're going to differentiate between different branches of statistics and identify types of data, measurement levels, the sampling techniques, and the difference between the observational and experimental study, and that's it. So the section covers basically statistics and statistical thinking, and it explains the process of statistics. So let's get started. So the process is simple. Again, all of this is posted. You don't have to write anything, but we want to go through them fairly fast. The process really involves three things. We are going to prepare, analyze, and conclude, and we have to be able to make some sense out of the results. It is really more than just simple calculations.
Data, collections of observations such as measurements, genders, or survey responses. Data describes characteristics of an individual. Data varies. Is everyone the same weight or height, etc.? Do we study the same number of hours every week?
Statistics, the science of planning studies and experiments, obtaining data and organizing, summarizing, presenting, analyzing, and interpreting those data, and then drawing conclusions based on them with some measure of confidence. Statistics also aims to discover sources of variability.
Population, the complete collection of all measurements or data that are being considered or studied. It consists of all subjects, human or otherwise, that are studied.
Census, the collection of data from every member of the population.
A sub-collection of members selected from a population is a subset of the population.
A variable is a characteristic or attribute of members of the population that can assume different values or can vary. Examples are height, weight, etc.
Okay, the thing I want you to get out of this is very simple. Normally in stats, we deal with the sample because we don't have access to a population. So what is a population? All. By the way, population doesn't necessarily refer to people. Could be population of texts. So population simply means to every object being studied. Sample, the simplest definition of that is a portion of that.
Given that we have 40 million smoke detectors installed in the United States, if 100 of them were randomly selected and tested, and 7 of them failed to provide an alarm in harmful conditions, answer the following.
What do you think in this situation the population is?
40 million smoke detectors.
40 million.
What about the sample?
100 of them.
100.
The sample would be the 100 smoke detectors that we check. So the idea is extremely important. What is the objective in general when we deal with stats? And the objective is it's very hard to get to the population. Either it's unavailable or it's a matter of time and money and the resources that we may not have. Therefore, the best course of action is to deal with the sample. So what do? We use the sample to draw a conclusion about the population. And that's really the idea behind the whole course. When we look at this idea of statistical and critical thinking, we have to get preparation, and to prepare, we look at the context, we look at the source, we look at the sampling method, how it was done. And after we go through that, then we will have to analyze. And to analyze, we may use graphs, we may look at what is given, whether we have a specific distribution, it's a normal distribution, or otherwise it's a binomial distribution. And then we use statistical methods with or without technology to do the analysis of the work. And finally, and more importantly, then we start writing a conclusion for our readers. Later on, when we do the test of hypothesis, we see that there are many steps involved. And the last step is coming up with the conclusion. And when we come up with the conclusion, it's important to put it in a terms that our readers can follow and understand, because some of them may not even know what happen as far as mathematical process involved. Okay, we want to explain it in a sense that it becomes nice and easy. Here's an example that shows that there are some boats involved in 10,000 and then fatalities that happen in ocean. So we want to look at the context when we look at this. And by the way, it's important to pay attention to the source, whether or not is biased or not, that's important. Generally speaking, stuff like this, which is explained and sent to the public and it's available for the public, normally it's unbiased and reliable. And a lot of statistics is done using the data that comes from those sources. The idea is that what does this table give us?
The table includes the number of registered pleasure boats, tens of thousands, and the number of manatee fatalities from encounters with boats in recent years. The format of the table suggests the following goal: determine whether there is a relationship between number of boats and number of manatee deaths from boats.
If you are exposed to research material and this stuff is given to you with enough practice and experience, you realize this is the idea behind it.
The data in the table are from the Florida Department of Highway Safety and Motor Vehicles and the Florida Marine Research Institute. The sources certainly appear to be reputable.
The idea is that where does the material come from? And that is extremely important when we look at the data. Where does it come from and why is that?
The data were obtained from official government records known to be reliable. The sampling method appears to be sound.
Generally speaking, they are given the task to do the job and they do it unbiased, and that's extremely important. Let's move on. As I mentioned, there's a lot of reading. By the time we finish it, it'll make more sense to you and what's happening. The first chapter doesn't have a lot of calculation. The idea of a voluntary response and what it is.
Voluntary response sample or self-selected sample is one in which the respondents themselves decide whether to be included.
What about the common examples? By their nature, they are flawed, and there are a lot of examples.
Internet polls in which people online can decide whether to respond, mail-in polls in which people can decide whether to reply, telephone call-in polls in which newspaper, radio, or television announcements ask that you voluntarily call a special number to register your opinion.
We may not have a lot of choices sometimes, and this may be the only way to collect data. But understand, in all these situations that we discussed, it's just voluntary. Generally speaking, most of the time, people answer when they have some sort of opinion about the concept. But as I mentioned, maybe we have no choice. We have no choice.
A news outlet asked viewers to call with their opinion about whether the UN headquarters should remain in the United States. Viewers then decided themselves whether to call with their opinions, and 63% of 171,000 respondents said that the UN should be moved out of the United States. In a separate, independent survey, 650 respondents were randomly selected and surveyed, and 41% of this group wanted the UN to move out of the United States.
Clearly, we see different results. What is really going on here?
The two polls produced different results, even though the news outlet poll involved 171,000 volunteer respondents. The much smaller poll of 650 randomly selected respondents is more likely to provide better results because of the far superior sampling method.
The idea is the method of sampling, the way it is gathered. Because when you ask people, in this case the viewers, to call, you wouldn't call unless you have a strong opinion about it. Either way, it doesn't matter, for or against it. That's why perhaps the second one with this one. And of course, the size is important, by the way. If the data collection is such that the sample size is extremely small, that may not be valid either. But this is fairly decent. After completing our preparation by considering the context, source, and sampling method, we start analyzing. And to do that, we use graphs. Normally, that explains a lot of stuff. And it is not just about according to what's happening nowadays, by the way, a strong computational skills. I want you to know that the common sense is extremely important. But in the old days, uh, and even today, we do have a lot of formulas. When we get to actual questions that they do use formulas, you'll see that the formulas are pretty complicated in some instances, especially towards the end of the course. It used to be that students have to remember the formulas. Now they are given the formula sheet, so they don't have to memorize it. It's all about understanding the process. Finally, we are going to look at the conclusion. And when we make up the conclusion, we have to look at the statistical significance versus a practical significance. And we're going to look at the definition, but in short, statistical significance is something that you see statistically a difference that occurs as a result of, when you look at a specific event. Practical significance is that the change that you have seen with respect to that statistical significance, is it large enough that will make it practical or not?
Statistical significance is achieved in a study if the likelihood of an event occurring by chance is 5% or less. Getting 98 girls in 100 random births is statistically significant because such an extreme outcome is not likely to result from random chance. Getting 52 girls in 100 births is not statistically significant because that event could easily occur with random chance.
How about this one? Practical significance?
It is
Please.
possible that some treatment or finding is effective, but common sense might suggest that the treatment or finding does not make enough of a difference to justify its use or be practical.
Let's look at an example.
The medical college admission test is a standardized test for medical students and is used to determine who is accepted into medical schools. To test its effectiveness, 16 students will take the MCAT test, then they complete a prep course, and they take it again. With the result of the average score for this group rises from 25 to 30 points. There's a 0.3% chance of getting those results by chance. Is this course effective?
Obviously, we look at the definition and that 0.3% is less than 5%. Because it's less than 5%, it does have a statistical significance. And now we're going to go from 25 to 30 points. From 25 to 30 points. That is an increase of 5 points. So that's a lot when you think about it. And so it is also practical. Now remember, practical significance ultimately depends on you. Remember, you are the consumer, you are paying to gain that increase, and you want to see whether it's worth your time, effort, and money that you're going to put in. That's the idea behind the practical significance. And that, by the way, could be subjective. I want you to pay attention to the fact that depending on the person, for some people, things may not be worth. For some people, even a couple of points of gain, it's worth it. So that, to a certain degree, is subjective.
IQ scores are normally between 70 and 130. A program that costs $40 claims to increase the IQ by 10 to 20 points. To test its effectiveness, 12 subjects were tested and showed to have an average increase of 3 points. There is a 25% chance of getting those results if the program has no effect. Is the program effective?
What do you think?
It doesn't have statistical significance.
And is it worth it?
No.
That's it. And this is what I mean. This is what I mean by the two situations, okay? Statistical significance versus practical significance. Now, I believe most people believe it's not practical. But if for any reason just a few points is good enough for some people, they may find it practical, so be it, okay? So that's important to understand. Very good. And so we got to move on. There are cases that we got to watch out for. So let's see what they are. Misleading conclusion. So in this case, misleading conclusions.
When forming a conclusion based on a statistical analysis, we should make statements that are clear even to those who have no understanding of statistics and its terminology.
When collecting data from people, it is better to take measurements yourself instead of asking subjects to report results.
If survey results are not worded carefully, the results of a study can be misleading. For example, there are more applicants for UCLA than UCI. Which school would you like to apply for?
Sometimes survey questions are unintentionally loaded by the order of the items being considered. Would you say air pollution causes cancer more than smoking, or would you say smoking causes cancer more than air pollution?
Non-response is there basically when someone refuses to answer or is unavailable.
Some
Please.
studies cite misleading percentages. Note that 100% of some quantity is all of it. But if there are references made to percentages that exceed 100%, such references are often not justified.
Okay, you probably have heard or have read something says, okay, this thing reduces something by 200%. It makes no sense whatsoever. Okay, and that's important for everyone to know. Descriptive statistic and inferential statistics. Those are really the two branches of statistics.
It consists of the collection, organization, summarization, and presentation of data. Descriptive statistics describe data through numerical summaries, tables, and graphs.
It consists of generalizing from samples to populations, uses methods that take results from a sample, extends them to the population, performing estimations and hypothesis tests, determining relationships among variables, and making predictions.
Descriptive, basically, we just describe using just tables, graphs, you name it. Whereas inferential, we want to make some sort of a generalization. And remember, we normally have access to a sample.
In a survey of 1,000 adults, subjects were asked how often they washed their hands after using a public restroom. 74% of the respondents said always.
So identify the sample, and in this case, the sample is 1,000 adults surveyed, and the population would be everyone, all adults. Part B, why would there be a better result by observing instead of asking? What do you think?
They probably would not admit to not washing their hands.
So yeah, that's it. Without a doubt, you're 100% correct. So here's the next one. We want to see if we have a potential bias. Basically, we have to look at the source.
Arsenic in rice. Amounts of arsenic in samples of rice grown in Texas were measured by the Food and Drug Administration.
We probably have no problem because it comes from a decent source. FDA?
Yes. An article in Journal of Nutrition, volume 130, number 8, noted that chocolate is rich in flavonoids. The article notes regular consumption of foods rich in flavonoids may reduce the risk of coronary heart disease. The study received funding from Mars Incorporated, the candy company, and the Chocolate Manufacturers Association.
So what do you think?
Yeah.
Yeah, okay. Obviously, there is a reason. Okay. Even if it's true, when you look at the source and where the money comes from and the funding, then you have to think about it twice. That's the idea. Okay, even if it's true. Again, so the source is extremely important.
Clinical trials. Researchers at Yale University conduct a wide variety of clinical trials by using subjects to volunteer after reading advertisements soliciting paid volunteers.
It's a voluntary response. So by nature, it is flawed. But when it comes to clinical trials, we may not have any other choices. Okay, that's important to understand. Again, it's a voluntary response.
In a survey of smartphone ownership, the Pew Research Center randomly selected 1,006 adults in the United States.
So there seems to be a decent method, sampling method by Pew Research Center is normally done properly. We don't know if it was done any way that was wrong. So it was done randomly. Randomly. That's the key. Part A.
Motorcycles and sour cream in recent years. There has been a strong correlation between per capita consumption of sour cream and the numbers of motorcycle riders killed in non-collision accidents. Therefore, consumption of forced sour cream causes motorcycle fatalities.
That's it?
No.
Perfect. So this is called an association, a correlation, and we'll discuss that later on. And even if there is, you can find correlation between things that they have nothing to do with each other. Eating ice cream and drowning, okay, they have nothing to do with each other, but you can find correlation. It doesn't mean anything.
The electronic cigarette maker V2 Sig, sponsored by a poll showing that 55% of smokers surveyed say that they feel ostracized sometimes, often, or always. The source sponsor have been interested in the poll results.
Yeah, exactly. The point being, what is the source? It is extremely important. Obviously, there are a lot of news that you find on social media nowadays. And it's becoming harder and harder to distinguish between the truth and what's being made up on a daily basis. So you want to be careful.
In a study, 560 human resource professionals were surveyed. Of those surveyed, 77% said that their companies conduct criminal background checks on all job applicants.
We are going to look at each case. It says, what is the actual number of the subjects? So what basic math steps are involved in part A? We simply have to do what?
0.77 times 560.
So that is that simple. You just multiply, you have the answer. So that would be part A. Now, could this be the actual number?
No, because you can't have 0.2 of a person.
Because it has to be discrete, okay? It has to be a whole number, an integer, a countable number. And so, therefore, what is the actual number?
431.
Perfect. You have to round it. When you round it accordingly. This one becomes 431. If it were 431 points, let's say 7, you would say 432. And how do we do the next one? 300 of the subjects are females. So what is their percentage?
I usually divide 300 by 431, so it's going to be about 70%.
By 300 is good. Divided by what?
431.
But originally we had 560, didn't we?
Oh, okay. So 50.
Let's go back to the original. Okay, the original question, the original sample size is 560. So 300 of 560 are female. So you have to divide 300 by 560, not by 431. Okay. And 431 refers to that a number that corresponds to 77%.
Professor?
Yes.
If it asked how many of the people who said that they conduct criminal background checks were female, would we then do 300 over 31?
One more time, I couldn't hear you somehow. If the question was?
If the question asked, what was the percentage of the people, of the professionals who said that they conduct criminal background checks on their job applicants, would we then do 300 over the 431?
No, the thing is 431 has got nothing to do with that. 431 out of 560, okay, said this is the case, okay? But all subjects.
I understand, but if it asked of the ones who said that they do criminal background checks, how many were female?
We don't know.
Oh, we wouldn't be able to do
No,
that?
this question doesn't tell you. It tells you that out of 560, 77% said this is the case. If you assume the 77% pertains to both males and females as an approximation, then you can multiply 77% times 300 and say, okay, that's the number of females, okay, who said so. Does that make sense?
Okay, all right, thank you.
Sure.
Continental Airlines ran ads claiming that lost baggage is an area where we've already improved 100% in the past 6 months. What is wrong with this statement?
In an editorial criticizing the statement, the New York Times correctly interpreted the 100% improvement to mean that no baggage is being lost, which was not true.
That's it. If it's 100% correct, that's it. No more problem.
A New York Times editorial criticized the chart caption that described a dental rinse as one that reduces plaque on teeth by over 300%. What is wrong with this statement?
I have a question. So if Continental Airlines used to lose 1% of baggages, and now it loses now it loses 0.5%.
That means it has been improved, okay? But it doesn't mean that it's 100% improvement means the way it is given 100% improvement, it means there is no more baggage loss the way they put it, okay? Instead, they want to say we lost 1% in the past and now we lose 0.5%. So it has improved by 0.5%, okay?
Percentage point.
Percentage point. Okay, now in this example, of course, 300%, that's impossible because that's 3 times. So you can't have something more than 100%. And how about this one?
When the author was negotiating a contract for the faculty and administration at a college, a dean presented the argument that if faculty receive a 4% raise and administrators receive a 4% raise, that's an 8% raise and it would never be approved. What's wrong with that argument?
What is wrong with this argument? It's not the 8%. They got 4%, right? They were from different groups. It doesn't mean that they add up. Okay, you got 4%, I got 4% raise. That's all there is to it, and no more.